Okay, we are looking at Chapter 4, Sections 1 and 2. We're going to cover congruent figures, and we're also going to cover 2 ways to prove that triangles are congruent, and that would be side, 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 and side angle side. Okay, the first thing is the definition of congruent figures. That is 2 figures that have exactly the same size and shape. When 2 figures are congruent, you can slide, flip, or turn one to have it match with the other. We'll be touching on that subject as we move through the packet here. Okay, so our first statement, this is what's called a congruent statement for the 2 figures, okay? So later you'll be asked to write congruent statements, and what we're looking for again is the connection between the 2. So when you say triangle ABC is congruent to triangle DEF, it implies a lot of information, and so again, you need to have your correspondences correct. Please note, we're going to talk about corresponding angles. They're not the same as the corresponding angles for parallel lines with a transversal. So when we write this statement, A is first, D is first here. What we're saying is angle A is congruent to angle D, so I mark them as being congruent. We also see that B and E are congruent. The second angle is congruent to the second angle, and again, I mark those. And then we also see that angle C is congruent to angle F. Triple marks for those guys. Now, in addition to corresponding angles being congruent, in order for these triangles to be exactly the same size and shape, we also need the corresponding sides to be congruent. So, side AB is congruent to side DE. Notice the first 2 letters, the first 2 letters. BC is congruent to EF. Again, notice second and third letter, second and third letter. And then the last set, segment AC, triple marks, is congruent to segment DF. Again, A and C are the first and third, D and F are the first and third. So, for our 2 triangles to be congruent, again, all corresponding angles must be congruent, and all corresponding sides are going to be congruent. Okay, the bottom of page 1, we also have information about writing congruent statements. Okay, so when you're referring to congruent polygons, you name the vertices in order, either clockwise or counterclockwise. So you can start anywhere you like as long as you're consistent. So when we write polygon CBDE, we're starting at C and heading to B. That's the short side of this figure. We then go from B to D. That's running across the bottom, for lack of a better description, of this figure. And then it goes up to D, across to DE, and again, DE is the longest side. So I want to follow the same pattern in this congruent figure. So I'd want to start at R and go to K, and that will run me across the short side. KO will run me across a medium size side, and then up OM across the longest side. So this is the proper correspondence. Now, it doesn't matter, though, what order you choose to travel in as long as the correspondences are correct. You'll notice, once I have this first correct correspondence, I could also say B, C, E, D, just wrapping around. I could then follow the same pattern over here, K, R, M, O. We could start D, E, C, B, running across the long side, across the second long side, and then across the short side. That would correspond to OM, RK. Okay? It would be incorrect to say that CBDE was congruent to RMOK, because that would be telling me that segment CB went with segment RM. And if I look at the picture, segment CB does definitely not go or correspond to segment RM. Okay, also don't forget, when you're naming polygons, start at a vertex and move either clockwise or counterclockwise. All right, we're going to move on to page 2. Okay, on page 2, we encounter what's called the third angles theorem. And it says if two angles of one triangle are congruent to two angles of a second triangle, then you're guaranteed the third angles of each triangle are also congruent to each other. Again, this is a logical extension from the triangle angle sum theorem, which says the sum of the angles of any triangle will equal 180 degrees. Well, in this triangle, I've used up 47 plus 57 degrees, which add up to be 104, leaving me with 76 degrees for the third angle. In this triangle, I've used up the same number of degrees, and therefore the third angle of this triangle must equal the third angle of this triangle. Okay, and again, it's logical that that would happen. So in words, I know that if angle B is congruent to angle X, or pardon me, angle Z, and angle C is congruent to angle X, then I'm guaranteed angle A must be congruent to angle Y. All right, so do keep that in mind. It'll come in handy when you're solving for angles. On to page 3. On page 3, we have two triangles that have been marked with the corresponding sides congruent, and we've also got some vocabulary about positions of the different parts. In this picture, we can see that segment AB is opposite angle C. We can also see segment AB is called the included side for angle A and angle B because it's actually hugging those two, being hugged, I should say, by those two angles. We can see in this picture angle A is opposite segment BC, and we can also say that angle A is included by side AB and side AC. Okay, so let's have you answer a few questions about this second triangle. So, my first question for you is, what side is opposite angle G? What side is opposite angle G? Okay, I wrote down a few questions for you. We're going to go ahead and go through them. So the first question is asking you, and that's the one we left off with, what's the side opposite angle G? So I look at the picture, I see angle G, I look across from angle G, and that would be segment FH. What angle is opposite segment GH? Again, I start at segment GH, I go across the triangle, and that's going to be angle F. Then it asks the next two about the included angle and the included side. Take a second, think about that. Okay, angle H is the included angle for, so I go ahead and I'm going to look at angle H, and the two sides that form angle H, the two sides that are including angle H, would be segment FH and segment HG. Hopefully you got that. And then I ask you segment GH, what two angles include it? So if I look at segment GH, the two angles that are grabbing segment GH would be angle G and angle H. Okay, moving on to the bottom of the page, we have our two postulates for proving two triangles are congruent. The first one's called side, 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 and you'll use the abbreviation SSS. And it says, as long as the three sides of one triangle are congruent to the three sides of a second triangle, then the triangles are congruent. So notice we're not, or we don't know to start that the angles are congruent. But what this is saying is that it's sufficient for the three sides to be congruent for this to work. So our side, side, side postulate then says, based upon the markings, again, you can go in any order you want to for the first triangle. So I went A, B, C, but you need to follow the same pattern in the second triangle. So by traveling through A, B, C, I cross the single mark and then cross the double mark. So I want to do the same thing in this picture and cross the single mark and then the double, which leads to triangle FGH. Okay, the second postulate is side angle side, and in this case we want two sides to be congruent and the included angle from one triangle to be equal to the same corresponding sides and included angle from the second triangle. Again, go in any order you want, but follow the pattern. So if we follow ABC, you start at the congruent angle, cross the single side, cross the side that's not marked. Following the same pattern over here, start at the congruent angle, cross the single side, cross the side that's not marked, and that will give you triangle FGH. Okay, the other examples that are in this packet, we will go over them in class, and we'll do some more practice problems in class. So, have a great day, and I'll see you in geometry class.